So symbolic mathematics, guys, is the way in which we use paper and pen. It's basically the following. So you imagine you have x squared plus 2x plus x. And then I tell you, okay, give me the derivative of this function with respect to x. And then you write it's going to be 3x squared minus x, etc., etc., etc. So the way we write in a paper is, this is basically what is symbolic mathematics. Got it? And you're going to see how interesting, how powerful is this one here to help us model some economic models and finance models also. Got it? So let's take a look to the, let me open MATLAB here and let me show you my screen. MATLAB. Here you go, MATLAB. So now let's assume, guys, for example, that I want to have a matrix, okay? But I want this matrix to be not with numbers, but with symbols. Okay, and the way we are going to define a symbol, we are going to tell MATLAB that we are talking with symbols, is with this command. It's going to be a string to sim. Okay, so this is str string to symbol. Okay, so change this string into a symbol. So in this way, MATLAB is going to know that we're going to be talking about symbols. So you do this, the apostrophe, and then let's define, for example, my matrix. I want to be A, B, C, D. Okay, so when I have a string, guys, the string needs to be into apostrophes. This one here is a string. Got it? And what I'm telling MATLAB is, okay, transform this string into a symbol. So I can do some mathematical operations on this one here. So you see, this is my matrix. It's a 2 times 2. And then this is a numeric. You can use also numbers if you want. You can use numbers and letters, whatever you can imagine. But you need to define this as a symbol. Okay, the way to define as a symbol, string, sorry, is this one here. And then you simply need to tell MATLAB, I want this string to be treated as a symbol. And then from here, guys, what we can do, for example, is let's call M1 equals determinant of M. Do you see that? So I don't have a letter, I don't have a solution. I have simply the mathematical formula of the determinant is A times D minus C times B, for example. Got it? So we can do, for example, M2. We can say, okay, what is the inverse of M? The mathematical inverse of M. As you can see, guys, is a vector of cofactors divided by the determinant. And this one here is the determinant, you see? Now, imagine, guys, that we want to have a, let's do a, perhaps let's do a function. Okay, so let's define a function. Let's say f, for example. Okay, and f is, I want to do an integral, for example, of something complex. Okay, let's say that x is simply x to the power 3. I'm just creating any function, guys. Oh, sorry, where's my x? X to the power 3 divided by a square root of, let's say, 1 minus x. Okay, let's assume that this is my function. Oh, sorry. Okay, so let's define this as a string first. And what I want, for example, is the integral between a and b of this expression here. Got it? So let's take a look to if the integral command is int. No, and then what I want is the integral of f in between a and b. So let's see if this is going to recognize like that. Yep. So this is the new. So we need to do a string to symbol. This one here. And then I have it. So what I'm doing, this int is integral, guys. So this is a finite or determined integral between a and b of this function. Okay, so give me 1 second. I will install my tablet. Give me 1 second. So which one I need to can move. So you can see what I'm doing. No. Just give me 1 minute for you to understand exactly what I'm doing. Okay, so now let me share my other screen. Okay, guys, you see my white screen?
Yes.
Perfect. Where's my mouse now? Okay, let me move this. Let me make this. Okay, so what we have done at the beginning, guys, is M. We define this as a string to symbol. Sorry, this is normal. And then we said, okay, I want this to be A, B, C, D. And then we basically, this is a symbolic matrix. And then from this symbolic matrix, I can do whatever I want. I can do the, I think I call M1 equals to the determinant of M. I can do any mathematical operation of these ones here. The inverse of M. Now, so what I've created, what I want to do is I call F, or what I want is F is a function that is simply x cubed. So what I wrote is cube square root of 1 minus x. And what I want is what I call FF, is what I want the integral from A to B of x cubed 1 minus x change on x. So this is what I'm defining, and I want to solve this one here. Got it? So this is what we have done here. So this is what we have done in MATLAB here. This is the integral of my function f in the interval between a and b. And so the answer is this one here. This is, of course, a very big answer.
Sorry, could you just scroll back up to your M1?
To
the M1.
Oh, yes. Here we go, M1, M1. Here we go.
Thank you.
M1 equals the determinant of M. Okay. Make sense, guys? So a symbolic is basically telling MATLAB, I want you to solve this in letters, not solve it like a mathematical, not numerically, just by letters. Later, we're going to learn how to do symbols into numbers, okay? At this point, let's get familiar with this type of notation. So we can do, for example, another one. Let's say I want to do the normal way of defining this one here can be symbol, no? And I want cosine. Yeah, the issue is that these new versions are changing, so I need to be careful. Symbol cosine of x. Okay, so I'm saying cosine of x is a symbol. Let me see, because I think that we need to use in this version the string to sim, but let's see. And I want to take the difference, differentiate this one, now let's do sine first. Do you remember what is the derivative of sine of x? Yeah, no, I need to define this one here. Sorry. I need to define this one here. Let me call S equals a string to symbol of sine of x. So I need to define first the string to symbol S. Now I can do ds equals the derivative of S. Remember, the derivative of the sine is the cosine. Can you do what is the derivative of the cosine of x? So the derivative command is diff. Remember, we did this in last class, so you need to take a look to the video, guys, just to make derivation. Yes, derivatives in MATLAB. Can you tell me what is the derivative of cosine of x in a single line? So let's call this DC. I want you to write in a single line the derivative of cosine of x. Someone? Okay, here I have in the chat something. Diff of S. Oh yeah, yeah, that was smart. Basically, this makes sense or not? So we have already defined S as a symbol. So you do the derivative of S is cosine, and the derivative of cosine is sine. Do you agree, guys? Another one that we can do is simply doing here. I will copy this one here. I can copy this one. And then instead of sine, I can write cosine. Make sense? So you can do this also. Make sense, guys? Now imagine that I want to take the derivative of okay, so let me show you my other screen. You can do this very quickly, okay? I want to change my screen and show you my other screen. Yeah, so let's assume, guys, that I want you to do the derivative, okay, respect to x, well, you know, of a function like this. I'm just creating sine of x squared minus cosine of 2x. I want you to tell me what is the derivative of that.
Sorry, I don't think you're showing your whiteboard.
Oh, you don't, oh, sorry, I'm not showing your screen, my screen. So this one here. You see, I want the derivative respect of x of sine of x squared minus cosine of 2x, for example. Someone? let's call this D2, for example. And what I want is the derivative of something, right? And then I need to be sure the MATLAB understands that I'm working with a symbol. So I will enter a string. A string is the way we write. I need to be sure that the string is understood by MATLAB and transformed into a symbol. And then it was, what was that? So it was, oh yeah, sine of x squared minus cosine of 2 times x, right? That's it. Oh, no. STR. Do you get this one here, guys?
I'm getting an error message, but I'm not sure if I'm just.
Can you show me your screen?
Yeah.
Yeah, can you show me your screen? Let me, wait, let me, yep.
Oh, I actually just figured it out. I just had an extra.
Oh, excellent.
Sure.
Yep, excellent.
Thanks.
No problem. Okay, let's do something different. For example, let's assume I define T as a string to symbol, just T. Okay, so T is now a symbol. And what I want is I want to take the second derivative of T to the power 6, for example. So I have T to the power 6, and I want to take the second derivative. So first derivative, second derivative. Make sense to you? So do you understand what I'm doing? So what I'm doing is the following, just to be sure that you understand what I'm doing. These are more things you're going to use later, guys, if you do some symbolic mathematics. So what I'm saying is the following. I have a function f that is equal to T to the power 6. Got it? So the derivative of f respect to x equals 6t to the power 5. Do you agree, guys? Now I do the second derivative of this one. Derivative respect to x is going to be 30t to the power 4. Do you agree? And so you continue taking the derivative of this one here. This is what I'm doing. So the second derivative, the number 2 that comes next to the diff represents how many times you want to take the derivative of the function. Make sense? This is what I've done here. Can you find the sixth derivative of T to the power 6? The sixth derivative should be simply take the derivative 6 times of T to the power 6, right? 720. We wrote a function, right? F. Let me see if I keep F, if I continue having F in my memory. Yes, F. So there is another variable, another interesting command, guys, that is called the sim var. The sim var, and I can do sim var of f. Take a look to what happens. So basically this command here, sim var, what it does is simply identifies in an equation or whatever you can imagine, is which is a variable here. So for MATLAB, the variable of interest here is going to be the variable x. So let's define another function. Let's call, I don't know, let's call f1, and let's call a string to sim. And I want this to be equal to, let's say, x to the power n. X power n. Okay, so this is my function. It's a symbol, x to the power n. And now what I want to do is I want to do f2, for example, and I want to take the difference of this one here of f1. Okay. MATLAB, what assumes are the common variables. So X, Y, and Z are the common symbols. Got it? So in this case, what it has done is simply it has taken the derivative of x to the power n. So remember, the derivative of this is n minus 1. Sorry, is n x to the power n minus 1. This is the result here. However, sometimes what you want to tell MATLAB is, you know what? No, don't use x, use n, for example. In that case, what you need to do is you need to tell which variable do you want to differentiate. So you need to tell, I want this variable to be my variable. So f1 has x and n, but I want not to differentiate respect to x, that is the default, but differentiate respect to n. And here you have another response. Questions, guys, up to now? Yeah, this is another thing that is important, guys. Let's assume that we define pi. Let's define this as I will define this as a simple string. 1 plus SQRT of 5 divided by 2. Oh, let me see. 1 plus SQRT. No, I want everything divided by 2. So this is the golden rule, guys. Okay. So this is my function. Now, take a look to whose. Take a look to what's pi. This one here is a character. It's not a symbol. You see? So if you want to evaluate a character or a string, you want to evaluate this. Okay, tell me what is this value. Okay, that's the meaning of evaluate. So tell me this value. When you have a character, guys, what you do, like in this one, like in this case, when you have characters, what you do is you simply call eval function. Eval p. And basically MATLAB, what it does, it takes the string and uses the numbers that are in the function and solves the function. This is if you want to use eval. Okay. Now, this way of doing this stuff, guys, using characters in symbolic mathematics is disappearing. Okay, I'm pretty sure that this is going to disappear in a couple of years. But this was the way in which MATLAB, old MATLABs used to do symbolic mathematics. You use strings, and then with the string you evaluate the strings. Got it? But there were a lot of limitations with this type of method, so that's why we use now the symbols. Now let me define P again, but not as a string, but directly as a symbol. So what I need to do, I know that this is a string, but I want MATLAB to transform this as a symbol. Okay. So now, if you take a look to whos, take a look to your pi. Now it is a symbol. Now, how do you evaluate symbols? Okay, and this is crucial, guys. This is something that we use all the time in programming for symbolic mathematics and economics. What we do is we say, okay, I want my symbol to be transformed into a polynomial. Of what? And what is the name of this one here? Of pi. So instead of using eval, instead of using evaluation, eval this one here, when I have a string, when I have characters or strings, I use the command that is called sim to poly. Okay, so if you just take a look, we arrive to the exact same conclusion. So let's define another function, I don't know, q. Let's say that q is, let's define this string as a symbol. And I will write here. So let's assume, guys, that I have 2x squared, whatever, 2 times x squared plus x cubed minus 3x, let's say plus 5. I need this. Or perhaps I can change my order. So just to make it. X cubed plus 2x squared minus 3x plus 5. Okay, so this is my q. Okay, and now I want to evaluate this function for specific values of x. But remember, what is q? If you just take a look to whos, q is a symbol. I cannot evaluate with symbols. Remember, if I have a polynomial, what I need is to transform this that is in symbols, I need to transform this into numbers. Do you agree? So basically in MATLAB, I want MATLAB to transform this into 1, 2, minus 3, and 5. Remember, this is what we did in a couple of classes ago, polynomials. So the polynomial is defined as 1, in this case, 2, the coefficients only, and the positions determine the order of the polynomial. Okay? So how do I transform this symbolic, this q that is a symbol, into a polynomial, into polynomial? Well, let's call this this is q. Let's call qp, and I told you sim to poly of what? Of q. Take a look to what happens. So this is the vectorial way of representing my polynomial. This one here. Is the coefficients 1 for x3, 2 for x2, minus 3 for x, and 5 for the number. So this is what you have here. And once you have this here, guys, okay, so we can create a sequence. Let's evaluate this into 1 to 100, okay? So I want to evaluate this function in between using numbers from 1 to 100. How do I evaluate this one here, guys? How do I evaluate a function with specific numbers? So my function is this one here, qp. And the numbers that I want to use to evaluate this function are these numbers here. So what I can do is I can call this h. Remember, the form you evaluate this one here is polyval. Polyval. What do you want a polyval? What is your function? My function is qp. And what numbers do you want to use? I want to use x. Okay, I will not print all the values. But what I can do is I can plot that. I can say plot of x and h. Where's my plot? Here I go with my plot. Do you see? So this is basically this function. cube, x cubed plus 2x squared minus 3x plus 5. Okay, please, guys, you need to review the videos that I send you. The videos are basically myself talking. It's the same. It's exactly the same as we do. Makes sense. Questions up to now. So you know how to create now, convert symbols into polynomials. You can evaluate a polynomial. You can do plots. You can do whatever you want. Now, guys, there is a very interesting MATLAB command that is useful also. Is that it's called the fplot command. I show you that in the when we did last class optimization. So the problem with plot, guys, the fplot. So let's do fplot, not plot, fplot. The problem with this fplot, guys, is that this works with characters. Okay, and I have a symbol. What is my function is what? My function is my symbol. What is my symbol? My function q. Okay, I want just to plot this. I have the symbolic expression of this q, and I just want to plot and see how this works in a given interval. So what I need to do as soon as this is a symbol, I need to say chart. First, chart this one, and then represent this between in the interval, let's say 0 to 100. So this is the way fplot works. Fplot works with strings or characters. So what you need to do first is transform this. This is a symbol. Transform this into a character, and then evaluate this in this interval. Oh, what is that? Fplot. Oh, not chart. Chart. No, wait a second. Yeah. You see, this is disappearing also. Everything that is character is disappearing, but up to now, it is able to do. So this is the plot that we have. So the command is fplot. The input must be a character. So that's why I have a symbol. I transform this symbol into character, and I want to evaluate this in this interval. And then your graph basically goes in this one here. So this is the way of directly using the symbolic mathematics into a graphical function. If you don't want to use the symbolic mathematics, that's what you need to do is basically you need to first transform the symbolic equation, this one, transform this one here into polynomial with sim to poly. You have numbers now. Once you have this polynomial equation, you simply create your x, evaluate using polyval, the function and the values of x, and then you can plot, you can do whatever you can imagine. Okay, so let me type again QP. So now can we go back instead of going going from symbol to polynomial? Can I go from polynomial to symbol? So going back reverse order. Yes, you can. So this is going to be called Q equation. I'm just QE. It's going to be I have a polynomial and I want this to become a symbol. And what I'm doing that is QP. And here you go. So you can go back and forth, guys. It is indifferent, back and forth. Okay, so now you are going to do a program. So let me show you my screen, my other screen. Okay, guys, create an M file. And your M file is going to be, so create an M file. Call this M file example eigenvalue. Okay, so this is your function. And let's do something simple. So use this matrix. So I want a matrix 1, 2, 3, 4, 5, 6, 7. So let's create this matrix. It's going to be 1, 2, 3, 4, 5, 6, and let's say 7, 8, 0. So this is my matrix. So you're gonna test with that and use the matrix inside your program. So let's do this much simpler. Okay, so the way you compute, guys, eigenvalues, okay, the way you compute eigenvalues is let's define a matrix mat, and mat is going to be A minus I lambda. Okay, so this is my matrix I. So this one here is going to be a symbol. This one here is an identity matrix, guys, the I matrix. Do you remember the special type of matrix? And then how do you find the solution? The solution, guys, is simply the solution is the roots of the determinant of mat. This provides you the eigenvalues. So do this. So you need to define this as a symbolic. So the way you define symbolic, guys, is simply, so if you want to define symbolic, I can call this one lam equals symbolic, and then you simply say lam. You know, this is a name. And then you have the lambda symbolic, you create your matrix like that. Once you have your matrix like that, this is symbolic matrix because you have a symbol here. Find the determinant, because you need to find that. This is the determinant. You need to find the determinant. And then once you have the determinant, find the roots of the determinant, and the answers are going to be the eigenvalues. Okay, let's say 5 minutes. Create your M file. Allow me 1 minute to bring some water. 2 more minutes, guys. Someone? I have one example. Okay. Let me let me check string lam. I size of A1, size of A2. Perfect. Mat determinant. Oh yeah. Up to the determinant, you're perfect. So what you need to do is once you have the determinant, you have a polynomial. Do you agree? And what you need to do is you need to find the roots of that. Abdi. Remember that the roots are basically the solution of a equation. Yeah, up to the determinant, you're perfect. So this is not still the eigenvalue. The eigenvalue is one step forward. Okay, 2 more minutes because I have some of you it's very close to the answer. So let me show you my screen. Wait a second, I want to show. Okay, 2 minutes, 2 minutes. 1 minute, guys. Some hint, Abdi, you need to transform because what you have defined as eigenvalue there, eigen, is a symbol, no? And remember that root works with a polynomial. So you need to transform the eigen into a polynomial with this sim to poly, and then you have the polynomial exactly. And then you are transforming, you need to name this something different. And then you apply the roots of that, and then you have the solution because the roots are the eigenvalues. One minute. Okay, so let's go. Where is share screen? Okay, guys. So take a look to this function. So let's evaluate this function. Okay, the function is called example eigenvalue. I have entered the matrix A. Okay, so I'm not calling anything. So I'm not using the input value here. No input here. Simply like this. Then I'm defining my lam. It's a symbolic. No, it's a symbolic lam. My matrix, MAT, is simply my A, this one here, minus I, size of A1. So it's basically 3 by 3, multiplied by lambda. Okay, so let's stop here the program. So we can run this one here up to this point. You see what I have created, guys? My A, oh, I haven't plotted A, but A is 1, 2, 3, 4, 5, 6, 7, 8. So when I do, it's going to be 1 minus lambda. The diagonal is going to be 5 minus lambda. And the last one is going to be 0 minus lambda, this here. So this is this one here, A minus I times lambda. Got it? So now what I do is I compute simply the determinant. So DD is the determinant, is minus lambda cube plus 6 lambda squared plus 72 lambda plus 27. This is a polynomial. Do you agree, guys? So what I'm doing now is I'm creating a vector that is called P. And P, what it does is simply transforms this that is a symbolic number, is a symbolic equation. I want to transform this one here into a polynomial. So if you can see, P is minus 1, 6, 72, and 27. So this is the representation, guys, of this DD. Fíjense, take a look. It's minus lambda cube, so it's minus 1, 6, 72, and 27. Minus 1, 6, 72, and 27. Got it? So once I have the polynomial, guys, I simply use the roots. The roots are simply I equal this number equals 0, and then you find the values of x that satisfy this equation. That's all. That's the roots of P. Just run the roots of this one here, and then you have your LNV is my eigenvalue. These are my eigenvalues, guys. 12 minus 0.38 and 5.73. If we want to check, so we can say, R1 equals, the command was eigenvalue of A. You see? Exactly the same values. So what I'm trying to tell you guys is that you can use symbolic math. If you don't have symbolic mathematics, guys, doing this equation here, just finding the eigenvalues is impossible because you need to have the lambda. The lambda is your x. Got it? If you don't have an x in your equation or you don't have a lambda in your equation, in this one here, where's my mouse? If you don't have a lambda here, there is no way you can solve this equation. So that's why symbolic mathematics is extremely important. Okay, 2 minutes to copy if you want to copy this one here. It's very straightforward program. Abdi, you were there. Huh?
Sorry, I just have a question. I'm a little confused.
Yes, go ahead.
So why, if you just wrote in R1 equals I of A, why did you need the lambda in the first place? Like, where does that come in?
Oh, no. Okay, so let me go to the, okay, 2 minutes. I do this by hand, okay? Copy if you want to copy this one here, and I will show this. Okay, so let me show you my other screen by hand. Just you can understand what I'm doing or what I have done. Okay, guys. So to find the eigenvalues, you need to build this matrix first. So the matrix is simply A minus I lambda. Okay, so this means I is going to be at 1 0 0 0 1 0 0 0 1 times lambda. Okay, so if you multiply these two, you're gonna obtain lambda 0 0 0 lambda 0 0 0 lambda. Do you agree? And then you subtract this matrix 1 2 3 4 5 6 7 8 0. You can do that, right? The matrix. So if you do, so my math at the end of the day indeed is going to be 1 minus lambda is going to be 1 minus lambda, nothing here, nothing here. 4 5 minus lambda, 6 7 8 0 minus lambda. So this is the matrix that you need to build. Make sense? In order to find the eigenvalues, this is the way you need to find this one here. Then once you do this one here, you need to find the determinant of math. Okay, here I will rely on what we find already. The determinant of, where's my mouse again? Give me 1 second. Oh, I need to run this again. Give me 1 second, please. Yes, so the determinant is going to be, guys, this one here. It disappeared. Well, I have DD somewhere here. Yes, it's going to be minus lambda cube plus 6 lambda square plus 72 lambda plus 27. Make sense? So if you do this times this times this, then this times this times this times this times this, etc. The determinant, the common determinant way. So you're going to find this equation here. And what you need to do in order to find the eigenvalues, what you need to do from this one here, you need to equal this to 0. And then you find the roots. So the roots basically, what values of lambda satisfy this equation? Make sense? So in order to do the roots in MATLAB, what you need to do is you need to move this one here. That is an equation. You need to do symbol to poly. And then when you do symbol to poly, you have minus 1, 6, 72, 27. And then you simply do the roots of this one here. And then you obtain your eigenvalues. Make sense?
Yes,
So
thank you.
the lambda is crucial. That's what I was telling to you. So if we have only I, no, I is not what I'm telling you. Is I times lambda, and lambda is a symbol. So we need to tell MATLAB somehow that this is a symbol, okay? Otherwise, MATLAB is not going to understand what is this one here. It's going to say, what? I have a matrix here, I have a matrix here. Well, what is this stuff here? Okay, that's why we need to define this as a symbolic. And once you have this symbolic, guys, everything becomes symbolic. This one here is also going to become symbolic. Everything is going to be symbolic until I tell, okay, change my symbolic into a polynomial. Guys, give me 1 second. Oh, yes, okay. Okay. So now you do another equation, another function. Yeah, let's start using the easy plot. Let's do this together. There is another command, guys, that is a very, very interesting, very simple to do. Okay, so let me show you my screen first. Wait, before doing that, let me lay down what I will do. Okay, imagine, guys, that we have the cost function. My cost function is going to be equal to q to the power q minus 12q squared plus 60q. Okay, so this is my cost function. Oh, sorry, this is minus, only one minus. This is my cost function, guys. Got it? And then do you remember there is this relationship between the marginal cost and average cost? Do you remember? Do you remember this famous graph? There was this famous graph, guys, that I have my average cost and my marginal cost. So this should be the same point. Do you remember this graph in micro?
Yes.
Okay, so these graphs come from here, comes from this one here, from the cost function. The cost function normally is a cubic function. The cubic function, remember, it looks like that, and then looks like that. Okay, so this is my cost function. So what we are going to be doing, guys, let's define. We're going to be defining the marginal cost. We're going to define the average cost. So the marginal cost is going to be simply the diff of c, right? So we need to be sure that this is symbolic. There needs to be a symbol. Then we can take the difference, the derivative of c, and the average cost is simply my cost divided by q, right? That's it. This is my average cost. And from here, we are going to do a couple of graphs using something that is called the easy plot that works with symbolics. Okay, so let's define this. So this is what we're going to be working in 1 minute. Okay, so let me show you my screen. Yeah, what I will call this function, I don't know, marginal cost, average cost, something like that. Okay. And what I will define here is, well, Q is going to be a symbolic, right? And then my symbolic is going to be, this one here. Q is a symbol. That's what I'm saying. Now I will define my C, my cost. I said, okay, this is also a symbol. And my symbol, here we're going to have some issues later, but it's going to be a symbol. What was my symbol? It was Q. I said it's Q what? Q to the power 3. Let me check here. Minus 12 times Q to the power 2 plus 60 times Q. Okay. So this is my C. Then what I will do is I will define my marginal cost. Let's call it marginal cost. My marginal cost is going to be equal to diff of C. my average cost is going to be simply my C divided by Q. Let's do a D here so we can test. So let's save this one here. Up to there, are we clear? So let's take a look how this works, if this works. So I have Q as a symbolic. I have my C. Then I have the marginal cost, that is simply the derivative of this one here. Yeah, sounds good. And my average cost, that is simply C divided by Q. Okay, this is good. And then what I will do, guys, is this command that is called the easy plot. Easy plot. Of what? Well, I will easy plot my MC. Let's say let's define this between 0 and 10. Then I want to graph, because this is going to be my marginal cost. Now I want to keep the graph open, so I do the hold on, remember that? And then I will do the other easy plot. Easy plot of average cost. Also in the same 0 to 100. And then I can write text, whatever you can imagine. Yeah, we can do some text here just to distinguish between which one is which. So let's say this is a dimension that I know, guys, because I've done this graph before. Okay, it's basically a position. I will show you in a minute what is that. This is in 7. X is 7. Y is 20. This is going to be my average cost. And this one here is going to be 860. You're going to see how this works in a minute. And that's all. Very simple function. Just to show you how EasyPlot works. Computer is dying. 1 second, please. Okay. Okay, so I will save and try to run. So let me delete the graphs. I don't need these graphs anymore. Let's run. Oh, what happened? Oh, yeah. So let me see what happens, because this is a new version of MATLAB, so I need to be careful. So my average cost. Wait, what happens here?
Your dimensions are not the same. It should be from 0 to.
Oh, yeah, of course, 0 to 10, right? Thank you, Abdi. Yeah, hopefully this time works.
And professors, one of those supposed to say MC in the text?
Marginal cost.
In the text.
Oh, yeah. So the first one is going to be, I think it's AC, and the other should be MC. Completely right. Okay, let's take a look. I'm not sure which one is which at this point. Let me see. Let's save and let's run. Interesting. Why is this? Let me see if my function is correct. Q minus 12q squared plus 60q. Interesting. It should have been. Y is going into different dimensions. Give me 1 second, please. Yeah, but why is this starting? Let me see. My marginal cost. Yeah, I see my marginal cost. The graphs look good, right? But the thing is that I have 0 to 10, 60q. I have q minus 12 plus 60. Yeah, and why is this divided by a different number? Let me see.
I think if both are set to 100, it looks better, the scale.
You get when you go to 100, you get the same result.
You don't get the same, but I think you can see the lines clear. Is that what you're trying to do?
Yeah, let's take a look if I put 100 to everyone. Yeah, let's take a look. No, it's too high. There is something funny here. Give me 1 second. Give me 1 second here. Do you get the same like me, right? That the value goes below my graph.
Yes.
Okay, so let me check what's going on here. It's q cubed minus 12 plus 60 times q. Interesting. Yeah, I need to explore what, guys. Okay, but this should work. The thing is, I'm going below. The marginal cost cannot be negative, for sure not. Q cubed minus. Interesting. Okay, let me check. Okay, let me check this. I will come back to you with this one here. But now it's clear, guys, the easy plot, how the easy plot works. You have the function. I have the diff of C. This is okay. Minus 12q, 60q. This is okay. So this is 2q squared minus 24q plus 60. So yeah, I will do this. I will do the math in a minute. Okay, guys, questions. So what we need to do now is I send you a lot of emails, guys. Sorry, a lot of documents. One of them, what I want from you now is to take a look. I send you several documents like that. The Leontief input-output model, conditions for profit maximization, log function, exponential functions, partial market equilibrium, relationship between marginal cost and average cost. This is the one that we have done, right? Can we open the Leontief input-output model? So at least let's do 2 or 3 so you can take a look. So what you can do is, please, look the paper, read the paper. Let me open the paper. So this is the model. Invest 5 minutes reading and understanding the model, and then basically try to solve it using MATLAB. I think I gave you also the code for this one here. But first, read, understand, and then you're gonna see the solution here is extremely simple. Okay, because the equation that at the end matters is this one here. You need to define what is T, what is D, using the example, this one here. So you define what is this is A. So what is T? Here is T. And then you simply find the solution for that. Got it? So 5 minutes to read first. We are talking about, this is called the Leontief input-output model. Okay. Please remind me to start the recording. I will stop the recording for a couple of minutes, okay? But remind me. Okay, guys, so the only thing that was missing here is basically I need to limit the axis. Okay, this is the x-axis, 0 and 10. And this is going to be my y-axis from 0 to 100. I need to force the y to go to 0. It's kind of weird. But let's take a look to what happens now. This is the only thing that I've changed in my program. So let's go. Here we go. You see? Now I have what I want. Now, before it was appearing to 25, and so 25, we didn't consider the 0 here, so my graph was going down. So now the graph looks correct. So this is my average cost, and this is my marginal cost, the blue line. The only thing that was missing is this one here. Simply define my axis. Okay? Okay, so now you can continue. 3 more minutes for a reading very quickly. There is only a very simple equation. So you just look for the equation and try to see what this equation is. Okay, guys, if you have read that one, can you please open? I send you one file that is called input output open economy. Do you see the program? Have I sent this to you? Can you check, please? Can you check if you have a program input underscore output underscore open underscore economy? Do you see that?
Yes.
Okay, so now you know the equation. So at the end of the day, guys, that the solution of the equation is this one, right? What is my equation? It's this one here. This is the final solution. So the location of inputs are going to be t minus 1 times d, and t is going to be I minus a. And you know all the mathematical derivations are here. To the minus 1 times d. So this is the equation that you're trying to solve. Can you please check that in the program? So what if the program is doing the correct thing? And remember, what you are trying to find is this weight, 0.3, 0.3, and 0.4. That's what you're trying to do. And the only requirement that you have here, guys, is the d vector, 10, 5, and 6. It is described in the description here. That's the only thing that you need. Two minutes, guys, to understand, and then we run the program. Okay, guys. So let's go. So hopefully we can have more time. So let me show you my screen, my MATLAB screen, and then we go on test. Do you see my screen? Let me see if I was recording. Okay, so basically, guys, we have this part here. This is my input output. The only requirement that I need is my matrix D. Basically, this D represents my final demands. So I know that 3 sectors are going to demand 10, 5, and 6. And basically what I need to compute is my production output. Okay, so this is my demand. I need to check my production output. Now I've done a little MATLAB more things here, is that I'm asking that I need to have 3. As soon as my A is going to be this vector here, my D needs to be minimum 3 elements. So that's what I'm asking here. If my size of D is not equal to 3, what I do is, sorry, D1. So this is the number of rows is not equal to 3. So perhaps someone entered this in a row vector. So you transform this into a column vector. Okay, then I do this is not needed, but you need to do that. The plot size of this one is not equal to 3. So basically what I need is a vector. We simply send a message saying, you know, that the matrix should be a 3 times 1 vector. And then we have the A. So this is my A input. My input, what is my A? What is called? This is my primary input. Okay. And then my primary input is 1 minus sum of A1. So what I'm doing here is, let me move this just to have a perspective of this one. So what I'm doing here, what is A? The primary input is going to be 1 minus A. So here, where's my theory here? This one here, 1 minus A. This is my primary input. You see my screen, right? Then T is going to be simply this one here. Sorry, X is going to be simply the inverse of T times D, T to the T inverse times D, and then you obtain your results. Make sense? Very straightforward model.
Sorry, Professor. So the part where it's 1 minus the sum of A, even though in the book isn't it I minus?
Oh, that one is this one. I3 minus A is this one here. So let's run. So let's take a look at what happens. Okay, look. Oh, I cannot run from here. I need to run from here. I define my D here. Let me enlarge this a little. This is my D. Do you agree? This is part of the example. This is my D. And now I need to run the model. As soon as I have an input, I need to run this from here, from the command window. Okay, so I do this, enter. So this is my E. Come on. My primary input, I think, yeah, my primary input is 1 minus sum of A of 1. Then my T is I3. So let's take a look to T. I3 minus A. And then X is simply the inverse of this one here times D. And then I have my primary inputs. I have X that is 0, 3, 0. Sorry. No, I need my inputs first. No, my primary inputs. It's going to be 0, let me see, times X. So I have the 21. I have this one here. X is 24, 20, and 18. So let's take a look if this works in a, where do I have my, oh, here we go. So let's take a look to the results. X1 is 2484, X2 is 2068, and X3 is 18.36. Got it? And then we have the weights times this one here. So this is what I'm doing here. The 0303. So my primary input is this primary input. So my primary input, where is my primary input here? This one. This is my primary input. So the way we compute the primary input is simply 1 minus the sum of A1. So if I sum A1, so let's take a look to what happens if I do this. So what I'm doing is I'm summing by column, by rows, do you agree? So take a look, 0, 2, 0, 5, 0, 7, 5, 7. This is 4 and 5 and 6. You see, that's what we're doing. And then 1 minus this part here gives me my primary input. And then if I multiply my primary input by X, this is what I'm requiring. So why I don't have this? So this is the total that I require, the total money that my economy has. Where is my paper? It should be somewhere around here. $21 billion. This one here. This is the required primary input. So let me put this in here. This is my required primary input. So let me save this one here. That is my primary input times the billions of dollars that I have per factor. Okay, so the thing is that once you read the paper, guys, what you need to do, and this is going to be part of your project, it's going to be simple. The project is simple, but when you have a paper or you want to do something, you need to first understand what is the model. Okay, once you understand the model, you need to basically model the model or program the model into MATLAB here. This is data, okay, so it's not a big deal. This is something that you need to compute here. So if you want A, can go also as part of the input arguments, do you agree? Etc. Make sense? Okay, so let's read another one. Let's read yeah, let's read this one here. Partial market equilibrium nonlinear model. This one here. Let's read this in 5 more minutes, guys. So it is only up to, let me see. Yeah, it's only up to here. It's not the quadratic formula. No. It's actually everything. Yeah, up to higher degree polynomial equations, basically up to here. Yeah, because we have the demand supply function. Yeah, you know what? Perhaps better if we start with another one. Let me check. Marginal cost. This one here. Let's do first this one here. Conditions for profit maximization. Yeah, let's do this one here. Okay, let's read conditions for profit maximization, guys. Let's say this one is longer. Let's say maximum 10 minutes, and then we come back. Let me stop the program. Guys, do you see my screen?
Yes.
Okay, so basically the profit maximization condition, guys, is this one here. So what I want is to find the maximum profit is when the derivative of my profit function is simply equal to 0. The first derivative equals to 0. The problem that we have is that we have 2 points in which the derivative is equal to 0. At this point K and at this point M. Now, in terms of my profit, my revenues and my costs, so what I try to do is the distance, the highest distance, the largest distance between my revenue and my cost function. Do you agree? And this happens when the derivatives are equal. Unfortunately, here is when we have 2 derivatives are equal here. you see? And here. So we just need to be sure that we are talking about this one here. Got it? And this one happens here when the marginal cost equals the marginal revenue, but that is not equal to 0. Because there is also 2 crossing points here. Do you see, guys? So we just need to be sure that my condition, my profit maximization condition is this one here and not this one here. Because it can be confusing. I can be finding the minimum profit. Make sense? So this is what we are trying to recreate using MATLAB, the numbers and the functions that you have here. So these are the functions we are going to have. I have my revenue function. I have my cost function. I can compute my profit function, this one here. And then I simply take my conditions, marginal utility equals marginal cost, marginal revenue equals marginal cost. And my other condition is basically that my second derivative of the revenues must be smaller than the second derivative of my costs. Basically this one here. This one here. Okay, so let's take a look to the MATLAB program. MATLAB program. Let's go and let's take a look to this one here. Okay, so here we go. So remember, this part here is simply a description. So my cost profit maximization, my first order condition is basically that marginal rate, my marginal revenue equals my marginal cost. And my second condition basically means that the second derivative of my revenues must be smaller than the second derivative of my costs. Okay. Then what we do is basically I'm defining. I'm using the revenue function, the one that we have 1,200 times Q minus 2Q squared. I'm defining Q as a symbol. I'm defining the cost, Q power 3, 61, Q power 2, etc. Also as a symbol. Q is symbolic. Then my profit function is the revenues minus my cost. Then I find my profit, my marginal profit, and my second derivative of my profit. Okay, so let's go up to here. So I have R, my revenue. I have my cost. I have the difference between these two guys. This is my profit. This is the first derivative of my profits. And this one here is the second derivative of my profits. Then I'm finding the marginal rate, the marginal revenue and my marginal cost. Let me move here. So this is my marginal revenue. And this is my marginal cost. And what I want, guys, is I want to equalize these two guys because this is my profit maximization condition. Do you agree? So this is a symbolic. What I need to do is I need to transform this one here into a polynomial. So this is my P prime numeric. Then what I will do is I find the roots of this one here. So let's take a look to what's going on here. So this is my P prime. And what I want is this one here to be equal to 0. Okay, so this is my first order condition. So let me work. So here are my two conditions. So I know that the roots are going to be equal at 36 and 3. So let me see if I have my function here. 36 and 3. So this is 1. And this is your 1. Got it? So I'm talking about what? P prime, the profit function. Oh no, I'm talking about this profit function. Okay, so let me check here. So this is my P prime, right? So what is my P prime here? Which one is my P prime? First derivative should be equal to 0. Oh, sorry. I'm looking here or here. So I have the condition of the P prime equal to 0 satisfied at 36. You see, or come on, or 3. So basically I have around here, my slope is 0, and around here, my slope is 0. Got it? So this is what I'm saying. Okay, so I have two possible solutions. I have this one here and this one here in which my first order condition is satisfied. So now let's go to see what happens here. This is the second order condition. So let me move here. So what I'm doing here is basically, this is my P prime prime. So this is the second derivative. And I want to evaluate this in each root. So I have two roots. I have 36 and 3, and I want to see which one is positive and which one is negative. And I have here minus 100. Minus 100 works with the first one. So with 36. And this one here has a 100 with the second one being 3. Okay, so what I need to do, guys, is I need to select the one that is smaller than 0. Remember, second order condition, when you are in a maximum, the second order condition is negative. Do you agree? So that's remember that. Second order condition, when you're in a maximum, should be negative. So what I'm trying to look for is this one here. I will select this one here automatically. So what I'm doing here is basically, I'm checking. If eval root 1 is smaller than 0, Q opt is going to be that. Otherwise, the other one is going to be the optimal one. Okay, so let's go here. So obviously here, my optimal is going to be at 36. So let's go. My, what is my Q optimal is 36.5. Got it? So in terms of the graph, so basically I'm saying my optimal is at 36.5. Yeah, now I need to find what is the Q that maximizes this value. So, okay, so what I will do is PNum, P is my profit function. What I need to find now is what is my P value, what is the maximum Q that maximizes my profit. So let me move this somewhere. I run this stuff. So my PNum, so this is my profit in numerical numbers. My Pmax is going to be evaluated. What is my maximum P when the optimal is 36? Basically, my function tells me that the maximum Pmax is 1.36. It's basically around this point here, 1.36. So when Q is 36, my price is going to be my profit is going to be 1.63 to the power 4. So this is basically 1,631. Make sense? So I know exactly now for this Q, this is my P, my profit, not price, my profit. Now I can find the revenues and costs. You know, we just can do, I have my revenue function, I have my cost function, and I can find my optimals, optimal revenue, optimal cost. Basically, I have it here. So it's my optimal revenue is 4.11, and my optimal cost is going to be 2.48. So basically, it's this one here. I need to see the values. 4.11 and 2.46. So 4.11 and 2.46 are basically these numbers here. So it's basically around here, 36. This distance here. So our optimal is, 4.11, yes. And the cost is 2.49. So these distances are the ones that are being computed. Because the profit is simply, remember, is that the largest distance between these two, the red and the blue, that maximizes my profit at this level. Got it? And then I do simply the plots and the graph, the easy plots, etc. And this is what you get finally. So the maximum profit is around 36. That corresponds to 2.3, I think, in profits. that coincides with the maximum distance between the revenues and the costs, and that coincides with my first order condition, that is my profit condition, that is marginal revenues equal marginal cost. Make sense? So are you able to run, and are you able to have these results here, guys? Can you run and be sure? Perfect. Okay, so guys, what I will do is I will send you at least 3, 4, or 5 more examples that you can start working with them. And for the final, next week we're gonna meet, and we're gonna meet with you, just with each of you 5, 10 minutes maximum. I want to basically understand what you are trying to do. But the basic thing that I require from your projects, guys, is the following. So let me go. Let me go back to share my. Give me 1 second. So this is what I require from your projects, guys. What I want you to show me is that you indeed understand how to program in MATLAB, and you know, if you migrate into R, it's very, very similar. Python is much simpler than this one here, much simpler, because almost everything is structured, except the data handling part. The data handling part is very similar to what we have done now. So what I want in your project, guys, so your project deadline is going to be, sorry, it's next Monday.
Professor, I thought our last day of class was this Wednesday.
Yeah, I know. But the thing is that the project, I normally give you more time. If you have your project for Wednesday, that's it. You can do it. But what I do is I give you more time for the project. So the deadline for the project, so the deadline, okay? So if you can do this early, much better.
Okay.
The deadline is 0701. This is Monday. Okay, and Monday should be very early. So it is basically 8 a.m. East. So basically I'm telling to you guys on Sunday, right? Okay. Now, you can, of course, do the project as soon as you want, starting from Wednesday. Much better for me because you give me time to review, to check, and to grade. Okay, so what I want is you to show me, guys, that you know how to use MATLAB. Okay, I don't care if the program is beautiful, it's not beautiful. I really don't care at this stage. I understand you're programming for first time in this language. So what I want is I need you to show me that you know how to handle data. So this means basically selection of data. So if you have a matrix, I want you to select specific parts of the data. You know, some matrix manipulations. Calling data from Excel. So when I say calling, I mean import, export. No, I want you to show me the use of some mathematical tools. You can do basically here optimizations if your program requires that. You know, modeling. So in modeling, guys, this implies if you can use some symbolic math. So I want you to use some symbolic math, whatever model, you know, and the model needs not to be necessarily a single model, guys. So you can have piece one. You know, I had a lot of students that last year, what they did is simply, okay, I have a very long program. The first part does data handling, you know, and you show me how the data is called is called in Excel, how you can save the data, how you can do plots. So plots, you know, subplots, just show me that you're able to do all this stuff. You need to give me, please, don't forget to give me the data. You need to give me a Word report. A Word report, it's you know, please don't write tons of pages. Simply tell me the model, the assumptions, and then basically the data that you use, the data used. Describe the data, okay? Some description of the data. And of course, you need to give me the Excel, or I need to be able to run, guys, your model. Okay, you give me your model, I put this in my computer, I run, and what I've done today on, line by line, that's what I do. I simply go and check, and I try to understand what you have done, etc., etc., etc. Make sense, guys? Symbolic, how to handle data. Yeah, the models that you can have, that you can use. The models are multiple. So, of course, I prefer some financial models. Nothing bad, guys, if you go online and check for a model. But what I need is you to understand what the model works, how the model works, adapt the model, use the model in this scenario of data handling, etc., or economic model. I will send you by today or tomorrow. Not today, I'm destroyed. Tomorrow, what I will do is I will send you more examples of previous work of your colleagues in the past years. They are very interesting models, and you can take a look to them. And if you want, you can adapt them, you can improve them, you can do whatever you want. The thing is that I want you to show me that indeed you understand how to program in MATLAB, how the data is handled, how symbolic mathematics works, how you can optimize models, etc. So that's it. It's very straightforward. Oh yes, and then please by the same date, okay, by the same date, guys, I need all your assignments, all your homeworks. Okay, so naming conventions, please, your naming convention should be the following. So it is a homework, for example, homework 1, and then you put your surname. Okay, now formats, for the first part, I'm okay with Word, but for the second part, what I need is M files. Remember the first part I was giving you some specific projects. In Word, what I want is basically the MATLAB code. So I need to be able to copy paste to my MATLAB code that I should be able to copy paste. Okay, you have most of you, not most of you, some of you, yes, it's some of you, it's not most, have already provided me the assignments, the homeworks. So, and just be sure that everyone has this one here. You can work in groups. I have no issue with that. But remember, guys, that the programming is not a group. It's not a group knowledge. It's an individual knowledge. Okay, you can improve, you can think and discuss, but at the end of the day, I want you, every one of you needs to present your own work. Make sense? So you have the videos. I will ask this video to be uploaded as soon as possible. So I will give to you, I don't know if it's tomorrow or Wednesday, but you have all the other videos, okay? All of them. So you can go and take a look to them, watch them, and then learn from them, and then ask me questions if needed. For next Wednesday, what I will do is I will send you a Google Doc, and then with the slots, they're very 5 to 10 minutes maximum. So you just give you the slots from starting at 6, and then we finish at 6:30 maximum. And then we chat about your ideas, what you want to do, if you want to do something related to another class that you are interested, or if you have done some other programs in another classes that you're interested to present in here, we can definitely discuss that. Okay. I had a lot of programs from Professor Shaw that they were developed by Professor. Well, students developed for the class of Professor Shaw, and basically here what we simply is modify the program in such a way that you show me that you can handle all this stuff here and improve the programs. That's all. Make sense?
So the meetings are Wednesday, you said?
Yes, Wednesday I will give you a early Wednesday. It's more likely that it's going to early Wednesday or tomorrow afternoon. I will provide you a Google Docs in which you just write your name. I will provide you I will provide you 7 slots, and then the first to come, first serve. You just pick a slot, and then I will be on Zoom on Wednesday. We chat, we discuss ideas, problems that you have, etc. And then basically you are ready to go. If you have specific questions, more than happy to answer them. Okay. More questions?
I had a couple questions on
Yeah,
homework
go-
assignment on
yes.
number 4, but I don't know if I
Yeah,
should.
please. Yeah, you go ahead. You can share your screen.
Oh, it was not really, I just wanted to clarify. So
Oh, yeah.
there's one that, there was one question that asked to make the program general.
Yes.
It was number 6. It looks to me like the program, it already can accept general, so I'm just not sure how
Oh,
you want us to modify it.
yeah, can you show me your screen
Sure.
just to be sure which one is you're
Yeah.
talking? So, and it's good that everyone is listening here, so everyone needs this stuff.
Sorry, just one second.
Yeah, no problem.
So this one.
Oh yeah, okay. So let me see. Generally deals with any matrix. Oh yeah. No, what I mean here, make it general implies input. Is X transpose doesn't receive any information from outside programs. You see, so just X transpose parentheses inputs. You know, just to make it generic. Makes
Okay.
sense to you? That's all.
And
yeah, and also the output, for example. Yeah, exactly.
Okay.
Inputs
And
and
then-
the outputs.
okay, and then what do you mean by array approaches?
No, we haven't done arrays in this class. Forget about that.
Okay.
Don't do that.
And
Yep. Yeah.
and then the
that
forwards
last part, no.
like are already here, right?
Yeah, everything. So the only thing
Okay.
is that you are going to be able to call this from outside.
Okay.
That's it.
And then the same thing with, I guess, sorry, wait one sec. I had another one written down. Oh, yeah, number 7, I'll share again. This one, make the program capable of receiving inputs. Same thing is, can it already?
Same. Oh,
Okay.
yeah. Yes, exactly the same stuff.
Okay.
What I want just to show you is basically you show me that you can input data into program. That's good.
Okay.
Perfect.
All right.
Okay.
Thank you.
Excellent. Okay, guys, any more questions? Okay. Perfect. So see you on Wednesday, guys. Please review the videos. Okay, you have a lot of information there. Just work together if you want, but create something interesting for you. Yeah, the other thing is that I'm really more geared towards understanding that you know MATLAB. So I have had crazy students that created, I remember one student created a horse racing program, just to bet on horse racing. It was very interesting. He did a lot of work on that, very interesting. Collected data from online, from the cloud. It was very interesting. So anything that even crazy ideas that you want to have and you want to test it, do it. Okay. The thing is that you show me that you know how to use MATLAB, and then if you know how to use MATLAB, guys, you're going to be able to use it in different environments. Okay. Okay, guys. No more questions? Perfect. Thank you very much. So see you on Wednesday. Take care. Have a good night.
Thank you.
See you guys. See you, Cameron. Bye, guys. Bye to Melo. Bye.
Bye.